If you have two resistors in series, then you're going to add the resistors. So 2 and 3 are going to come out as 5. If you have two resistors in parallel, you're going to go 1 over R parallel is 1 over 2 plus 1 over 1. Rearrange it and then invert your answers. So the answer is 3 over 2. You then need to make it 2 over 3, which is 0,67 ohms. If there's something weird like this, where you're going to have one resistor, let's say that's 2 ohms, and on the next branch you've got a 3 ohm and a 4 ohm. Then you would calculate that by going 1 over R parallel is equal to 1 over everything on the top branch plus 1 over everything on the bottom branch together, which is 7, because those two are in series with one another. Right, moving on. If you have got 3 amps coming along and 1 amp goes to the bottom branch, you can say that 2 amps goes to the top branch. You have 12 volts coming along here. 4 volts is used by that resistor, which means that there are 8 volts left for the top and the bottom branch of this parallel network. You're then in a position to work out the two resistances, and R1 is going to be 8 volts divided by 2 amps and 4 ohms, whilst R2 will be 8 volts divided by 1 amp, which is 8 ohms. Taking a look at this, we have got 2 volts on the one parallel resistor. On the other branch, there's 6 volts altogether, meaning that that must be 4 volts because you must have the same amount on both branches. So altogether, the parallel network uses 6 volts. There's 2 volts on that series one, which means that altogether we are going to have 8 volts on voltmeter number 1. The series current is the same at all points of the series circuit, and then you're going to go along and you're going to say there's a split over here. You don't know enough information, so you're going to have to do something there. You're going to go R is equal to, I is equal to V divided by R, which is 4 divided by 2. So this turns out to be 2 amps, which means it's 2 amps on the bottom branch as well. And then I'm able to say R2 is equal to 6 divided by 2, which is 3 ohms. And R3 is going to be equal to 2 divided by 4, which is 0,5 ohms. And on this one over here, you can say R is equal to 2 volts divided by 2 amps, 2 volts, 2 amps, and you land up with 1 ohm. If we now open switch 1, what is going to happen? Switch 1 is over here. That means that if I make a break there, nothing will work any longer because it's on the main branch of the circuit. However, if I open up switch 2, I will only eliminate this top branch of the parallel network. Everything else will continue to work just fine. But you're going to now, because you've taken away a parallel resistor, actually things have got more difficult. So the total resistance of this circuit has increased, which means that the current strength will have decreased slightly. So there's less parallel resistance, therefore more total resistance, and your ammeter readings will actually decrease.